Hello and welcome to the Pedagogic table. The element helium was firstly observed in 1868 by P.J. Janssen. It was observed by the studies of the sun, leading to its name. The name is influenced by the Greek word helios, meaning sun. Helium is a light, inert, colorless gas, and it has the lowest melting point of all elements. It has a valence of 0, making it behave like a noble gas.
Okay, so we're also going to investigate helium a bit further now. Now, I've just filled this balloon up with helium gas from this canister. Now, helium, when breathed in, as most people know, actually makes you talk in a Mickey Mouse voice. And the reason for that is the vocal cords actually vibrate faster in helium medium compared to air. Now, I'm not allowed to inhale due to the fact that I'm a responsible teacher. But I have a student here who is allowed to inhale. So, here we go.
Thank you for letting me participate.
You're welcome.
Helium occurs naturally in the Earth's crust as natural gas. It is the second most abundant element in the universe. Most of helium was made in the Big Bang. Today, it is made through fusion of hydrogen in the stars. Helium is rare in the atmosphere because the Earth's gravitation is not strong enough to keep the light gas. A common way of gathering helium is from the Earth's crust. Since helium doesn't make compounds known to man, it is always gathered in its pure forms.
Right, so for the next demonstration we're going to in fact look at the element helium, which is a noble gas, element number 2 in the periodic system, and a very unreactive gas. So for comparison, we're going to compare it with a very reactive element, which is hydrogen, which is element number 1, the most common element in the universe, and also very explosive. So let's first start by filling up a balloon with the gas helium. So here we have helium, and here we have a balloon. So we're going to begin by filling up the balloon. So, now helium is very unreactive because it has a full outer shell of electrons. Chemical reactions are all about electrons being shared or accepted or received. So, since helium has a full outer shell, it wants to do none of those things. It's quite happy as it is. It's also a very light element. Now if we do the same for hydrogen, we fill a balloon up here. Now hydrogen actually has 1 electron in its outer shell, so it does want to react. It wants to get a full outer shell by either losing 1 or actually gaining 1. And it can do that by sharing or actually giving and receiving electrons. So let's fill this balloon up with hydrogen and make a hydrogen balloon creature. I have to go slow here. Okay. So here's our balloon creature. Let's just tie it. Hydrogen, like helium, is a very light element. It's less dense than air, so it floats up when you let it go. So what we're going to do now is we're going to actually combust them. to see the difference in reactivity. First we'll start with the helium, and then we'll combust the hydrogen, and you'll be able to see the difference between them. So, for safety reasons here, I'm going to use this long stick, and I'll start with the helium. Try and move it away here so it doesn't affect the hydrogen. So let's start here with the combustion of helium. Remember, helium has a full outer shell, so it doesn't want to react. It will pop. That's not a chemical reaction, that's just the pressure of the balloon. So, let's try the same now with hydrogen, and you'll see an obvious difference.
Helium is most commonly used in balloons to give them lift. Because of its inert nature, it is also used in welding as a protective medium. A more extreme use of helium is in the CERN particle accelerator as a cooling medium. Because it is chosen because it has the lowest freezing point of all elements, and is therefore a liquid at a temperature of -271